All right, so here we are at number 26, and 26 we've been given the square root of 486 x squared. And again, the directions are express in simplified form, assume that all variables represent positive real numbers. All right, well, if you take a look at your chart, and the chart that I use unfortunately doesn't go high enough to indicate whether or not 486 is a perfect square or not. So if you were to put into your calculator the square root of 486, you'll find out that it unfortunately is not a perfect square. So since 486 is not a perfect square, we know that we're going to have to break this radical into good stuff and bad stuff. But we can still use our chart to find what the largest perfect square is that we can multiply by some other number to get to 486. And if you go down your chart, you want to start again at the highest number and work your way down. And as you work your way down, you're going to find that 81 is the largest perfect square that you can multiply by some other number to get to 486. And so 81 times 6 gives us the 486. So now that we've broken the number part, our coefficient, down into 81 and 6, let's go ahead and take a look at our x squared. And this is the first time that we've been introduced to a variable under our radical. When you're working with your variable and an exponent, you want to go back to your index, and again, in this case, our index is 2, and you want to start thinking in multiples of this index. So if our index for 26 is 2, you want to start thinking in multiples of 2, 4, 6, 8, etc. And so now go back to your exponent and you ask yourself, is this exponent a multiple of my root? And in this case it is. And when your exponent is a multiple of your root, you take all of that and put it into your good stuff radical. All right, and we'll talk a little bit later about what you do if your root, or rather what you do when your power is not a multiple of your root. But I don't want to get into that right now because it'll make more sense when you actually see it in an upcoming problem. So for right now, just know that when your power, your exponent, is a multiple of your index, take all of that and put it into the good stuff. You don't have to worry about putting anything into the bad stuff. All right, so now we've broken this single radical down into good stuff, bad stuff. And let's just double check. We have 81 times 6 gives us the 486, x squared, so we have everything we need to break this down. Well, when we're going to break down the good stuff, we know that everything in here is going to come out nice and clean without any radicals. So what is the square root of 81? Well, hopefully you know by now that that is 9. If not, go back to your chart. We're dealing with the second power, right? Go down to 81, go down to 81, follow it over to the left, and you'll see 9. When you're breaking down your variable, what you're going to do is you're going to divide your power by your root. So in this case, we have our power is 2, divided by our index or root, which is 2. And what is 2 divided by 2? Well, that gives us a 1. So when our x comes out, it comes out with a power of 1, but we don't really have to write the power of 1. So we're going to go ahead and leave that off. And then we know that we just simply rewrite our garbage. So in this case, radical 6. So our final answer is 9x radical 6. All right, so if this was a little confusing for you, go ahead and either rewatch this video or watch the next couple videos, because there are several more examples where we deal with breaking down not only numbers, but breaking down variables and their exponents into good stuff, bad stuff. So go ahead and take a look at some of those, and I think by the end of all of these examples, you'll be comfortable with them. But in this case, we end up with 9x radical 6.